In today's lesson, we'll be learning about the point of intersection with a focus on equations. In a previous lesson, we learned that a point of intersection can be found in 4 different ways. Today, we'll be finding a point of intersection with substitution, which involves using equations and algebra. The first step is to convert the equations to slope-intercept form, which is y equals mx plus b. The equation of the blue line appears to be already in slope-intercept form, and the equation of the red line also appears to be in slope-intercept form, which means we don't have to do anything for our first step. Sometimes you do, sometimes you don't. The second step is to substitute one equation into other equation and solve for x. We're going to begin this step by either choosing to use the equation of the blue line or to use the equation of the red line. It doesn't matter, the choice is up to you. I'm going to choose to use the equation of the red line. I'm going to rewrite its equation exactly as shown. Y equals 0.25x plus 2. The next step is a little bit confusing. We already know that y is equal to 0.5x plus 1. We also know that there's another y over here. We are going to substitute or replace this y with 0.5x plus 1. So instead of y, you're going to replace it with 0.5x plus 1. Everything on the other side of the equation will stay exactly the same. At this point, you need to look for like terms. You'll notice that positive 1 and positive 2 are like terms, while 0.5x and 0.25x are like terms as well. Like terms like to be together, but you also have to remember that generally speaking, you want to keep variables and numbers on separate sides of the equation. Which means I'm going to move 0.25x to the left to be with 0.5x, and I'm going to move positive 1 to the right so it's with positive 2. Now, when you move a term to the other side of an equation, it becomes the opposite. 0.5x hasn't moved, so it's still the same. Now, 0.25x is now negative 0.25x. The positive 2 hasn't moved, so it's going to stay the same. And positive 1 now is negative 1. I don't need the positive sign in front of 2, so I'm going to erase it. I can now simplify both sides of the equation. So 0.5x minus 0.25x is going to give you 0.25x. And 2 subtract 1 is going to give you 1. I'm going to divide this by 0.25 since the opposite of multiplying by 0.25 is dividing by 0.25. And what you do to one side of an equation, you must do to the other side of an equation. These are going to cancel out, which leaves you with just x. And 1 divided by 0.25 gives you 4. Therefore, x is equal to 4. We're trying to find the point of intersection of this blue and red line. A point of intersection contains 2 numbers. We have only found one of these numbers. We now need to find the other number. The third step is to substitute our value of x into any equation and solve for y. We just found that x was equal to 4, which means I can put this number into my equation for my blue line, or I can put this number into the equation for my red line. It actually doesn't matter which one you choose. I'm going to choose to use the blue line. Since we know x is equal to 4, I'm going to replace x with the number 4. So y equals 0.54 plus 1. This looks a little bit strange. This looks like 0.54. However, there is a multiplication sign in between these two numbers. You'll want to follow BEDMAS here, which means you need to multiply before adding. So we are going to multiply 0.5 times 4. And that is going to give you the number 2. The plus 1 stays the same. And now we can simplify this. 2 plus 1 will give you 3. Therefore, y is equal to 3. Earlier, we found x was equal to 4. And just now, we found y was equal to 3, which means we have enough information for the point of intersection. The fourth step here is to state your solution as a point. We found x was 4 and y was 3. Therefore, the solution, or point of intersection, is 4 and 3. The very last step is to check your solution with a left side right side check. However, we won't be covering this in today's lesson. I've gone ahead and graphed my blue line and I've graphed my red line, and as you can see, the point of intersection is 4 and 3.